So today we'll see the finite automata with output variation of automata. Basically, automatas are nothing but the mathematical model of a system designed in terms of finite number of elements, wherein finite automata can be used for recognizing the languages as well as generator of the languages. So under the finite automata as a generator of languages, we have FA with output, wherein there are two major categories of such machines or such automatas. Those categories are referred as Mealy machine and Moore machine. As the name indicates, these basically represents the named after the people who have introduced them. Mealy machine was introduced by George H. Mealy in 1955, whereas Moore machine was introduced by E. F. Moore in 1950s. So what is different between these two? Basically, the difference majority comes under the way of output dependence of these machines. When we say Mealy machine, here the output is dependent upon the transition, and also it is represented on transition as we have shown here in the case of this, that from Q0 on the input of X, the output generated is Y and the transition is moving to Q1. So this is basically Mealy machine. Whereas in case of Moore machine, the output is associated with state. So they are represented along the state, like here Q0 slash dash. What does it mean? That Q0 is not associated with any output. Whereas Q1 slash Y, this indicates that output Y is associated with Q1. Ultimately, these both transitions which are written will do the same work. Like Q0 on the input of X generates output Y, and state transition to Q1, whereas here what we are doing, Q0 again on the input of X, it is going to state X where the output associated is Y. So basically the difference is in the way output is associated, output is dependent in the machine, whether it is a dependent or associated with state or transition. Based on that, we can clarify or we can classify the machines as Moore machine and Mealy machine. In case of Moore, the output is associated with state, whereas in case of Mealy machine, the output is associated with transition. So that's the difference between Mealy machine and Moore machine. We'll see examples of this Mealy machine and Moore machines, and it will clarify how basically to go for construction of Mealy machine as well as Moore machine. Let's see the first example. Here, the definition which I have given is construct Moore machine as well as Mealy machine, which will count the occurrences of substring 001. Also write the tuple for both the machines. So what we will do is, say being first example, we'll go for construction of Mealy as well as Moore machine for this, and we'll see how the tuples for these both machines can be written. So let's start with Moore machine. What does Moore machine says that in case of Moore machine, the output is associated with what? Associated with state. That means each state represents some output associated with that. So let's go for it. What does it say? That we need to count the occurrences of 0, 0, 1. What we'll do here, that whenever we are getting any input string, we'll check for the occurrences 0 followed by 0 followed by 1. If it is the case, we'll generate output as a 1. Otherwise, the output will be 0. So basically at the end, in the output, as many ones we have, we'll assume that those many occurrences of 0, 0, 1 is available. Okay. So let's go for it. Q0. Since Q0 is the initial state and we cannot just say anything whether we have zero number of zeros or zero number of ones or any other thing. What we will do is we'll simply say that output associated with Q0 is nothing. Now the first input may be either 0 or 1. Right? Here what we are doing is we are checking for the occurrences of 0, 0, 1. Okay. So when we say 0, 0, 1, basically what we are saying, let's go for first 0 out of this 0, 0, 1. So on 0, we are assuming that the transition will go to Q1. Since our objective is to look for 1, 0, which is preceded by 0 and 0, this will not work for us. So next would be again another 0 will be looking for Q2, and when we get third input as a 1, we will say that we have an occurrence of 0 followed by 0 followed by 1. So in this Q3 will generate output 1. Otherwise, what output should be generated? We can either keep them as a dash, dash, and so on, which means that if we are not generating any output, we'll keep it dash. If we are getting counter as a 0, 0, 1, in that case only we'll generate 1 as output, which will signify that 0, 0, 1 has been occurred for once. Okay, now let's go for the other cases. What would be the other cases? If your first input is 1, doesn't matter to us, right? Still we need to look for 0, 0, 1, that is 0 followed by 0 followed by 1. So we can write here simply, let's say Q4 dash, we'll have some output. We'll discuss this case later. On the input of 1, we are going to Q4. Still we are looking for 0 followed by 0 followed by 1. So if any 0 comes in Q4, which may be the first 0 from 0, 0, 1, so we'll show transition here on the input of 0. When we have 1 at Q4, it is of no use because it still means that we are far away from 0 followed by 0 followed by 1. So let's show that on the input of 1, we are roaming around on Q4 only. We are not going for verifying whether 0, 0, 1 is come or not. Next, this is for Q4 and Q0. We have shown both the input 0 and 1. Let's see Q1. If in Q1 we get 1, then what? It will signify that it is nothing but 0 followed by 1 and not 0 followed by 0 followed by 1. We will go to the state wherein we are coming after occurrence of any 1. From where we'll again search for 0 followed by 0 followed by 1. Next, Q2. In Q2, we have shown transition for 1 because this is the case wherein it was 0, 0 and 1, or this 0, and 1. So basically, if we get 0 here, what does it will signify? It will signify that we have come here with the help of first 0 followed by second 0, and we are getting third 0. Now, this third 0 is violating the criteria of 0 followed by 0 followed by 1. But it may be the case that this 0 is amongst the 0 which we are receiving like this 1, 2, 3 followed by 1, wherein not this is matching to our criteria, but this would match to our criteria. So basically, if we have single 0 or any number of zeros here, still it will satisfy our criteria of 0 followed by 0 followed by 1. So what we will do for 0 over here, we can have a clean. So it would be either 0, 0, 1 or 0, 0, 1 or 0, 0, 0, 0, 0 followed by 1. Still, this one will indicate that it is a 1 which is coming after at least 2 previous zeros. So we'll go for generating 1 as output here. Now let's look for Q3. What will be the case when Q3 has input as a 0 or input as a 1? The case is very simple. We have already checked for 0 followed by 0 followed by 1, and we have generated 1 to signify that we had one occurrence of 0, 0, 1. After that, what would be there? If any 0 is coming, we need to recheck for 0 followed by 0 followed by 1. And if we are getting 1, we have to go to the place from where we are again going to start the verification of 0 followed by 0 followed by 1. So we can simply say that once we receive this 1, we'll go to Q4, wherein we are again looking for 0, 0, 1, or any ones are coming. We are having clean of 1 at Q4. If we get 0, we may need to start verification of 0, 0, 1, because that 0 may be the part of next 0, 0, 1 sequence. So this is basically our Moore machine equivalent to the given description. Now this is just a transition diagram of Moore machine. How to write tuple definition for that? The tuple definition says that Moore machine can be given as Q summation delta, right? Q summation delta transition function followed by output function. Okay, and since this is a FA with output, it will never have final state. So how to show this? This is summation delta Q0, this thing. Okay, so let's try to go for writing these cases. What is Q? Q is finite set of states, wherein we have Q0, Q1, Q2, Q3, Q4 as the states. Q0, Q1, Q2, Q3, and Q4 as the states. Summation is a finite set of input symbols, where inputs are nothing but 0, 1. This we are representing as a delta, which is nothing but output function. So what outputs we are generating? Here we are assuming that we are generating just one output. That is 1. Okay. Delta is what? Delta is the transition function. This whole thing is nothing but the transition function. Okay. With mapping Q cross summation gives Q. Lambda is output function. With mapping. Now what mapping do we have? Output is associated with state. So Q gives output is what? Represented by this output symbol. So this is delta gamma and initial state from where we're starting. This will come here. Here Q0 is our initial state. Okay. Now how to show this delta in terms of output function and transition function. So we have Q0, Q1, Q2, Q3, Q4 are the states, right? We have output function gamma represented here. We have delta represented here. Two inputs are there, 0 and 1. Output associated with Q0. If you look at this diagram, this is dash. We just have output associated with Q3. We can write here 1, and all others are nothing but dash, dash, and dash. Now this Q0 on the input of 0, we are going to Q1. Q0 on the input of 1 is Q4. Q1 on the input of 0, Q2 on the input of 1, Q4. Q2 on the input of 0, we have Q2. On the input of 1, we have Q3, where this Q3 is generating output as a 1. Q3 on the input of 0, it is Q1. On the input of 1, it is Q4. Q4 on the input of 0 is Q1. On the input of 1, it is Q4. So this is basically the transition function, and this is the output function for Moore machine which we have constructed. Okay. Now what we can add here? Here, although we are saying no output is generated here, because we just want to count zeros. We can have another assumption that if the machine encounters 0, 0, 1 sequence, it will generate 1 as output. Otherwise, it will generate 0 as output. In that case, the construction can be represented like this: 0, 0, 0, and 1, where initial state will not have any output. Here, output alphabet can have 0, 1, and on these cases, when the input doesn't have 0 followed by 0 followed by 1, in that case we can have 0, 0, and 0 as the output. So this is another way of representing the same function, right? So it is a construction of Moore machine for the given description. Now we'll go for construction of Mealy machine for the same case. Okay, for that I will keep this construction of Moore machine as it is, and I will just remove this tuple definition from here. And we'll construct the Mealy machine. Now, what does Mealy machine stands for? Mealy machine says that output is associated with transition. That means the way we are represented here in case of Moore machine, it will not be there in what it would have. It here in case of Mealy machine, the output would be represented on the transition in the place of state. So what is our required thing? Our required thing is that we need to check for 0 followed by 0 followed by 1. Okay, so let's construct for that first. Q0, 0 followed by 0 followed by 1. On 1, we'll say that we have encountered with 0, 0, 1. Otherwise, we'll say keep the inputs as it is, because that is not the case which we are looking for. Q1, Q2, Q3. Okay, if we get 1 here, we can very well show it here itself. Initial one, so output generated should be 0 because it is not satisfying our criteria. We are looking just for 0 followed by 0 followed by 1. Then here if we get 1, again go back to the place wherein we are looking for 0, 0, 1 again. If we get 1 here, we are shown. If we get 0 here, the same description which I talked about, this same explanation can be given here for 0. Generate 0. And in Q3, if we get 1, go to Q0 with 1/0. If we get 0, that would be first 0. So we should go to the place wherein we are coming after receipt of first 0. In the case when our input corresponds to 0 followed by 0 followed by 1, we are going to generate 1. Otherwise, in all other cases, we'll generate zeros. This is our Mealy machine equivalent to the given description. Now, capital Q would be same. Definition of Mealy machine is also given in the similar Q summation output alphabet delta followed by number followed by Q0, where capital Q is similar here. Capital Q is finite set of states consisting of Q0, Q1, Q2, Q3, Q4. Q4 is not there, so Q0, Q1, Q2, Q3. This would be our capital Q, that is finite set of states. Summation is 0, 1, finite set of input symbols. This is output set of output symbols. What outputs we have? We have again 0 and 1 as output. 0 signifying nothing. 1 signifies that we have encountered 0, 0, 1 at once. Then we have delta, lambda, and Q0. Q0 is initial state. Delta having transition function is having mapping of Q cross summation gives Q. Is this clear? Similarly, output function has mapping of Q cross summation gives Q. Or Q cross summation gives output function, that is output set alphabet. And the transition function and delta functions diagram we have shown. We can also write it in the form of table. The tabular representation I will have here. This is your Q, wherein we have Q0, Q1, Q2, Q3 as the states. Then on the input of 0, we have next state and output. Similarly, on the input of 1 also, we can have next state and output. Okay. Q0 on the input of 0. Q0 on the input of 0, we are going to Q1. Q1 with output generated as a 0. Q1 on the input of 1, we are Q0 on the input of 1, we are remaining on Q0. Output generated is 0. Q1 on the input of 0, transition to Q2. On the input of 1, transition to Q0. So Q0, Q2, and the output generated is 0 and 0. Q2 on the input of 0 is Q2 with 0 output. Q2 on the input of 1, it is Q3, output generated is 1. Q3 on the input of 0, we are going to Q1, output generated is 0. Q3 on the input of 1, we have Q0 with output generated as 0. So this is basically the tabular representation of Mealy machine. So here we finish the example related to Mealy machine and Moore machine construction, wherein we are counting for the occurrence of 001 substring in the given input.